Yeah, good morning, Steven.
Hey, Dave.
How are you today?
Oh, pretty good. You can hear me?
Yes, I can hear you fine.
All right. Yeah, things are well on my side, on my end.
Good.
Did some practice questions yesterday, and realizing um it's just a matter of practice. Like I think I have just it's been a while since I've actually practiced some arithmetic and stuff like that. So I make small mistakes here and there, but it's not all that hard.
No, it isn't. In fact, when you look at the prep books, they say that all the math you ever needed to know, you learned by the ninth grade. And that might be a slight exaggeration because I would say maybe by the 10th or 11th grade.
Yeah.
Because it's all algebra and geometry and arithmetic. The one extra thing that they do emphasize on GMAT is number theory.
Okay.
You want to know what positive numbers times positive numbers are, what negative numbers times negative numbers are, what a positive plus a negative, things like that.
Okay.
What are positive numbers, what are integers, what are primes, that kind of number theory.
Yeah.
But
And,
that
and
really, go ahead.
it was some of those themes that I think got me off guard. For example, like how do you distinguish between the sizes of fractions, like when they're really close to each other,
Mm-hmm.
and you wouldn't know unless you put it into like a decimal form that it's off, one's bigger than the other, like in the hundreds place.
For
Another
example,
issue I had was
so for
that
example, you're saying something like, which is the bigger number?
yeah, they gave me a list and they're like, which number's the biggest and which one's the smallest.
Right, right, right. Yes, that's the number theory kind of stuff that they do. Incidentally, I forget to mention this to most people, but on this control panel that you're looking at
Uh,
for GoToMeeting, at the top there's a little orange arrow. If
okay.
you click that, it will condense the thing so that it doesn't take up as much of your desktop.
All right. No, no.
It's a toggle switch. It opens and closes. The control panel is still open. It's just minimized, so it doesn't block as much of your screen.
Okay.
Okay. All right. Well, let's pick up from where we left off last time with problem solving. We did
Also,
20. Go ahead.
could I give you six like ideas that I knew I was having trouble with, and maybe if we run into them, we can emphasize going over it.
Yes. Let's do it.
You work like that, cause
Sure.
yeah. So I had so for one of my issues was fractions. Another issue was negative exponents. How to work with those. Um, Percentages. Rates of like work, how long it takes somebody to get something accomplished, and then the last one is like probability and how probability grows. Like there's one's like 1/6 of a chance, and then the other one's 1/9 of a chance.
What kind of goes along with probability is combinations and permutations. And
Yes,
it
that's
used to be, when I first started working with Eric, their highest degree of difficulty problems was combinations and permutations and probability type problems. I think in the
okay.
last year or two, they've kind of gone to prime numbers. If they want to ask a really difficult question now, they'll ask you about greatest common factors or prime numbers. So the test has evolved a little bit over the last 4 years. But even still, you do need to know a bit about combinations and permutations and probability. Let's just address one or two of these. Negative exponents. The one thing about negative exponents is they have nothing to do with negative numbers. They mean one thing and one thing only, the reciprocal. So if I take 2 to the minus 3 exponent, it's the same as writing that reciprocal like that.
Oh, that's right.
Okay, and this is a positive number. That is 1/8. So that's the only thing you really need to remember about negative exponents, is just make it a reciprocal with a positive exponent. Fractions, if I am multiplying two fractions together, I'm going to multiply their numerators and I'm going to multiply their denominators.
When you're multiplying them.
Yes. If I am dividing them, then I'm going to flip this one and multiply. So that's the same thing as 2/3 times 4/3, which is then 8/9. So multiplying and dividing are actually pretty straightforward. It's easier to multiply and divide than it is to add. Because if I'm adding fractions or subtracting fractions, I need to find a common denominator. So I'm going to multiply these two to get a common denominator, which would be 12. And then 1/3 becomes 4/12 because I divide 3 into 12 to get 4 and multiply 4 times 1 to get this numerator. Whereas 1/4 becomes 3/12. So that answer would be 1/12. And addition is pretty much the same thing. Ooh, boy, my dog was chewing on my stylus. I don't know if you can see it or not. I tell you, these animals. And it's affecting my ability to erase a little bit. I actually, she chewed on the cord to this thing and broke it. I had to go out and get a new digital tablet this weekend. But yeah, luckily she chewed on my old stylus, so I have a completely new set. But anyway, yeah, and as we come to some of these others, percentages are really straightforward, actually. If you want to find a percentage, you move the decimal point 2 spots to the right.
Okay.
So 0.43 becomes 43%. 4.126 becomes 412.6%. That's all you need to know about percentages.
Okay.
Rates. Let's wait until we get to a problem that is involved rates of work. A typical problem would be John is able to paint a house in 3 hours. Bill is able to paint the same house in 4 hours. If they work together painting, how long will it take them to paint the house? That's a very typical rate problem. That's actually not a hard problem. It comes down always to finding out how much they can do in a given unit frame. Let's look at that problem I just mentioned. What did I say? Tom and Bill? Tom 3 hours.
Yeah.
Bill 4 hours. Okay. The way to solve this is figure out how much Tom can paint in a unit period of time, and in this case in 1 hour. In other words, we're not going to select 1 minute. We're going to figure out what he can paint in 1 hour. How much of the house can he paint in 1 hour, Tom?
Well, you said I don't know.
If he can paint the entire house in 3 hours, then he paints 1/3 of the house in 1 hour.
Okay.
And if Bill can paint the whole house in 4 hours, he'll paint 1/4 of the house in 1 hour. If they were both working separately. Okay, well, if you put Tom on one end of the house and start painting, and you put Bill on the other end of the house and start painting, at the end of 1 hour, we're going to have 1/3 of the house painted by Tom, and we're going to have 1/4 of the house painted by Bill. If I add all of those together, we're going to paint 7/12 of the house in 1 hour.
Okay.
So how long would it take to paint the entire house? Flip this over, 12/7 hours.